Hello everyone, welcome to series of video on uh, Latent Dirichlet Allocation LDA. This is the fourth video of this series. Uh, in the last video we started discussing the corpus generation and plate diagram, and as I said in the last video that there are LDA assumes makes some assumption to on how a document typically generated. That's a simplified assumption, and the assumption has basically two parts. One is the setup part, and then we have the document generation part. We discussed the setup part in the last video, and that's where we stopped. So let's proceed from there. So let me go till the point where we stopped our discussion. So, okay. So we'll just have a quick recap as well. So the first setup part is uh, we have a topic word distribution, and it's represented as a matrix here. Second setup is document topic distribution, and it's represented in a matrix form. And then we have length for each document which author wants to generate in the corpus. So this is where we stopped. Let's proceed further. So this is what the setup part. Now once we have this setup, how document is generated as per the LDA assumption is as follows. So author takes a document to be generated, takes a index of the document to be generated. Let us assume that that index is 1. So the D is equal to 1. So D is equal to 1 means that author starts writing the first document. So to write the first document, we refer the document topic distribution, means for the first document, when in other words the theta 1, theta D is the topic distribution for the dth document, and so theta 1 is the topic distribution for the first document, and it is something as highlighted here, this one. So as per the setup, author has decided to prepare the first document having probability distribution for the topics as follows: 0.6, 0.01, 0.09, 0.3. So that's what we take as theta 1. Then for the first document, author has to generate the first word. He has to generate each word in sequence. So let us start that first word has to be generated. So n is equal to 1. If we remember the notations in the, I think in the second video, there I had said that the word or the term of a document would be indexed by small n. So that's why this small n is equal to 1 here. That means now we are in the place first term of the first document. And to do that, author draw one. First, author has to decide from which topic this word, this term of the document has to come, and that topic will be generated as per the document topic distribution. In another word, author would draw one sample from the document topic distribution of the first document, and while drawing a sample, that's basically in this LDA, we follow a multinomial distribution, and multinomial distribution has a parameter of vector of numbers, vector of probability of occurring each of the different probable event to occur. That's a generic definition. That's a generic property of the multinomial distribution. Now here in this case, the probable events which can occur is automobile, health, real estate, or common. These are the topics. In other words, what we can do that to draw one sample for the topic for first term of the first document, let us throw a dice of 4 face. 4 face because we have 4 topics, and each face of the dice has the probability as mentioned in the document topic distribution matrix, which is theta 1 here, because we are generating document for the first document. We are generating word for the first document. So when we draw the dice, when we throw the dice, the 4-face dice parameterized by the probability of 4 faces as 0.6, 0.01, 0.09, and 0.3. Let us assume that dice gives the number 4. Then this will make us to conclude that the topic is represented here as Z, index Y for the first document D is equal to 1, and within the first document the first term is equal to 1, means Z11, the topic for the first word of the first document is equal to 4. That's what drawing a sample from the multinomial distribution parameterized by theta 1. Now let me highlight one second. Now let us focus to the plate diagram. So we parameterized the draw of the draw for the topic from document topic distribution, means from theta. So that parameter leads us to get ZDN. And that's what the dependency is shown here in the plate notation. And this ZDN will be for each term of each document. That's why it is indexed as Z, the topic, within the topic, Z, the document, and within the document, the term. Okay, so we decided the topic for the first term of the first document. Now, next step is to decide. So author decided that we are going to pick the first term of the first document from the topic indexed by 4, and the index topic 4 is nothing else but the common topic. Next step is from the common topic which word to pick up, which word we have to write in the document. We got the topic. Now let us draw one sample from the topic, the decided topic common. Now let us focus to the topic word distribution for the topic number 4, means K is equal to 4. Now K is equal to 4 has distribution something like this: 0.02, 0.03, 0.01, 0.02, 0.05, 0.06, 0.5, 0.31. So this gets as a parameter here as phi K is equal to 4 is something like this. It's a vector of a probability distribution. Now the next step, we have to sample a word from this distribution as per this distribution. It's the same kind of process as we sample the topic for the first term of the first document in this step. Now the difference here, now we have to draw one sample from a multinomial distribution parameterized by phi4, which has 8 numbers of parameters. In other words, let us roll a dice having 8 faces. Probability of each face is mentioned here. And on rolling the dice, what value comes up? Let us observe that. So let us assume that when we roll the dice, 8 faces dice, we get the value as 7. That means we term that as a phi k is equal to 1, v is equal to 7. That means sorry, phi kv. Phi kv is we have 0.5. We got the word as 7. That means that word is he. When k, I'm sorry, there's a mistake here. It's not k is equal to 1, it's k is equal to 4 here. That's why I was getting confused. So let us, excuse me for that. So this is phi k47. So phi k47 is for the fourth topic, 7th word is he here. So that's the word we get when we sample a word from the topic word distribution for the topic common. Now, so that's the word we sampled, and this word distribution. See, this word is sampled based on 2 things. One, the topic index ZDN. ZDN here is 4, and then the phi, the topic word distribution. And that's why now let us focus to the plate diagram. The plate diagram has dependency for the WDN, means the word for the dth document for nth term, WDN. It has dependency on ZDN and phi. Based on that, the word gets sampled. So as we sampled the word he, for the first document, first term, author decides to put the word he. And that is how. So far we have derived the first word for the first document, but the first document has 11 words. So let us repeat this process till we generate the all words for the first document. So we will repeat this process 11 times, or we can say that we will repeat this process till the number of the document selected, number of the terms of the document selected, and every time we sample a word, it will come to the respective list. For the second iteration, whatever word comes here from this process, this will come to this place, then third, then fourth, like this. And once we complete the first document, repeat this complete process for the all documents of the corpus which we want to generate. This is how we will complete, this is how we will, LDA assumes this is how a document gets generated. It may not be right. It's an imaginary situation. We imagine that we imagine that this is how a document gets corpus gets generated, and based on that, LDA proceeds further and decides the topic. And how? So what do we mean by that? That we assumed, okay, this is what is going to happen. Now let us focus to this diagram. Now we can see the all other things are not colored, all the other events, but WDN is colored here. It means this is the only one thing which we observe in the real world. And based on this observation, task of LDA is to find all the other values which will help us to understand, or which will help us to derive topic or any other things which we can find from the LDA model. In another word, we observe the document and the respective term, and based on the assumption what LDA makes and which we discussed just now, based on that assumption, LDA gives us broadly two things: topic word distribution and the document topic distribution. These are the broad two things. We can derive some other things also, but mainly these two things LDA gives us from the document term matrix what we observe. So this is what about corpus generation and plate diagram. I understand so far that we have talked many terms such as beta, alpha. These are the two hyperparameters, but I did not discuss much in detail about it. We'll have much more understanding about those things in the coming videos, in the next videos of this series, where we are going to follow the document generation process in R, and based on this setup, we will derive the document term matrix. And once we derive the document term matrix, we will do the reverse corpus generation. Means assume that okay, we have observed document term matrix. Purpose of LDA that we find this. Now let us reverse the corpus generation process and get the topic word and the document topic matrix, which maximizes the likelihood of observing this sort of corpus. So that's it for this video, and thanks for watching. In the next video, we will discuss this more in detail when we do the steps in R language, and we will discuss further the next things. Thanks a lot for watching. Please watch the next video coming up.